All right, these pretty much come down to quite an interesting result. So let's have a quick look. NCN is going to be n factorial over n factorial, and n minus r factorial is just going to be 0 factorial, and we know that 0 factorial is 1, so n factorial over n factorial is just 1. And if I look at NC0, what I've got is n factorial over 0 factorial and n minus 0 factorial, and again I get 1. Now let's have a look at C and D. If I've got 9, choose 3, what I've got is 9 factorial over 3 factorial, 6 factorial. This is going to be 9 factorial over 6 factorial, and 9 minus 6 is 3 factorial. So hopefully you're starting to see a little bit of a pattern coming over here. If we have a look at E, we've got 15, choose 5, and that's going to be 15 factorial over 5 factorial, and 15 minus 5 is 10 factorial. And if I look at 15, choose 10, I've got 15 factorial over 10 factorial, and 15 minus 10 is 5 factorial. Then if I look at the last two, I've got 12, choose 7, which is 12 factorial over 7 factorial, and 12 minus 7 is 5, and 12, choose 5 is going to be 12 factorial over 5 factorial times 7 factorial, because 12 minus 5 is 7. And this has got to do with the symmetry in your Pascal's triangle. But basically, it can come down to the fact that if we have 12, choose P or NCP, and 12CQ, as long as P and Q add to 12, they're going to be equal. Okay, so NCP, in general, NCP will be equal to NCQ, where P plus Q is equal to N.